Hi, my name is Meenal Khona.
Hello, my name is Arvind Jayanti.
Hi, I'm Sanika Tamankar.
We are Group 21, Limitless, and today we'll be going through our application blogging. So this is the architecture of our application where we are using Amazon services. And yeah, so let's start with the architecture. So I'll explain components one by one, and at the same time, I'll be going through the console services as well. So whenever user hits our application URL, the request is being sent to Elastic Beanstalk that returns the minified code of our application. So let's go through the Elastic Beanstalk here. So I've opened this in the console. We have provisioned the Elastic Beanstalk. These are the different versions of our application. This is the version that has the latest code in it. And here is the URL of our application through which the user can access the application. So currently we are using HTTP, and because the TLS certificate costs a lot. So that's the reason our application is not secure right now. So this is the link of our application. So Elastic Beanstalk uses the image from the ECR. This is the image that is being used for deployment of our application by the Elastic Beanstalk. Now the next component, we'll go through the Cognito. So for user authentication, we are using Amazon Cognito, from which we are triggering a post confirmation lambda that this lambda inserts the details of the user in the DynamoDB table users. So here, this is the Cognito console. So this is the Cognito console. Here are the settings of our application that we have done. These are the required attributes. We have set the minimum password length as 8, and these are the password policies, uppercase letters, lowercase letters, and so on. And here I've added the trigger, that is the post confirmation trigger, through which the details of the user is being added to the database table users. So this is the configuration of Cognito. Here we have configured the client settings. This is the client ID. And this is the domain name setting that is required for sending the email to the user whenever user signs up. So Cognito uses this domain to send an email using which the user can confirm its access to the application. So this is about the Cognito. I'll go through the post confirmation lambda. So this is the post confirmation lambda that inserts the user details in the users table. Now the next component that we'll talk about is API gateway. So we are using API gateway to route the user's request to the particular lambda. So we have configured an API gateway that has multiple routes to it, and also we have added authorization to it. So only authenticated users can access the Lambda functions from the API gateway. So this is the API gateway. Here we can see that there are multiple routes that we have configured. And this is the authorization JWT auth token that will be generated by Cognito. So after user logs in, Cognito returns a session that has a JWT token in it, and that JWT token is used to trigger the request for the services. And these are the integrations. Here we have integrated the Lambda functions based on the routes of our application. The next components that we have is the S3 bucket. So whenever a user posts a blog, we are storing the image in the S3 bucket, and while displaying, we are fetching it using the S3 bucket URL, image URL. So this is the bucket. So yeah, this is the images. So here we store the images and we have kept it public. So user can access the images in our application. So here it has been downloaded and yeah, this is the image that we store in S3 bucket. And for that, we are using the Lambda function. Post image. So this Lambda function will put the image in the S3 bucket and return the success message once it's uploaded, and we can then access the image through the URL. Okay, so now I'll go through all the Lambda functions one by one. Post blog, we covered the post blog, like whenever user posts the blogs, this Lambda will be called. So currently we are uploading a zip file in it because we require multiple dependencies added in package.json. So we have uploaded a zip file here in the code. Then we have the get blogs Lambda. So yeah, so this again here we have the zip file uploaded. And yeah, so these are the different Lambda functions that we are using. This is used for liking the blog. So whenever a user likes any blog, this Lambda is triggered through API gateway. This is for commenting on the blog. This is for this we have covered. This is for email. So yeah, so whenever our customer registers to our application, we create an SNS topic for that particular user. So there are two different mails being sent. One is the confirmation email and second is the subscription email. So if the user chooses to subscribe to our application, the user will receive emails for whenever any user posts a blog or someone else likes the user's blog. So these emails are being triggered by AWS SNS service. So yeah, let me. Yeah, so we create topics based on the user ID that is being returned by the cognitor. So each user has its own topic. So wherever we want to send notification to suppose this user, we publish it to this topic, and the subscriber will be the email ID of the user. So accordingly, the emails are being sent to the user using the SNS service. Just a moment. Yeah. So we have covered this part. Yeah, then we have the DynamoDB tables. There are two different tables. One is users and one is blog. So all the user information is stored in the users table, and all the blog information like followers and all the followers information and along with the user information are stored in this user table. Then we have the blog information where we store the comments, different comments provided on the blog, the ID, and the likes, whoever liked the post, we are storing it in here. And these are the details that are being stored in the blog database. So this is the overall architecture of our application. So Arvind and Sanika, would you like to add anything else here?
I would like to add one thing. See, the S3 we upload images is only public read, so users can't publicly add the images to the bucket. They can only read the images. To add the images, user has to provide an the authentication for the website. That's the only thing I want to add.
So to give application overview, we have built a blogging application blog site that aims to connect bloggers together on a single platform. We have features like a user can create blogs, read blogs of other users. They can follow other users. They can like and comment on the blogs they found interesting. And the notification will also be sent when the blog is liked or when the new blog is posted. So this is our UI of our application, which we have built using React.js, and the Lambda functions are built using Node.js. So let me sign up. So when I sign up, an email will be sent. So there would be two emails sent to my sent to the uh, sent to the user. One is subscribe. So yeah, once user subscribes to the topic, he can receive emails on the special events like if the blog has been liked or if he posts a new blog. And second is verification email. So the user has been confirmed. Now I'll sign up again. Sorry, I log in my account. So these are the blogs posted by other users. So this triggers Lambda function like get all blogs, which will return the blogs from DynamoDB. Another feature that we have is post blogs. So if I post, can also insert images that are stored to S3. So the blog that I posted, yeah, blog that I posted just now. Now another feature that we have is follow unfollow. So a user can follow another user and he can also unfollow. Then he can delete his own blog using delete functionality. He can like blogs of another user, comment on so or like. So on when for all these CRUD operations, different lambda functions are triggered and the data is posted uh, fetched from DynamoDB. So yeah, if I like uh, log of another user, then the notification will be sent. So something like this, so that I like. Okay, so when I like a new blog, I receive the notification saying that someone liked your blog. So one more feature that we have is delete. The user can delete his own blog, or like the blog that he has posted. The blog is deleted, and another feature, like I've covered almost all the features. So if the user logs out of the application, the session is cleared and the then the login page is returned. Um, so yeah, I guess that's it. That are all the features that we have.
So let's start the cloud formation part of the presentation. So this is the cloud formation file we have created for our project. So I'm just going to create a stack. I'll use the upload option. So here I have to give some parameters. The IAM role, I need to provide lab IAM role. Beanstalk application name that the stack is going to create. Beanstalk environment name. The domain name for the Cognito pool. And finally, the S3 Beanstalk bucket name, which stores the front-end code. So I'll just show the S3 bucket. So in this bucket, we store the Docker run part of the front end. So it specifies from which ECR repository the code is going to be fetched and at which port the container exposes the application. So I'm just going to start the stack. So while the stack is getting created, I am going to explain the cloud formation part. So there are some parameters which I have configured, which we have configured for the stack, and the DDB user and DDB blog are the tables which are configured to uh, store the user data and blog data as explained by Meenal earlier. And the post confirmation lambda, this creates the lambda function which will be triggered after the sign up user sign up is done. Then this is the Cognito configuration for the cloud formation. As you can see, email will be triggered and all. And this is the Cognito domain and the Cognito app client configuration. Uh, these are configured to the Cognito user pool by getting the ARN. And this is the post confirmation permission is created for the Cognito. By default, Cognito doesn't have access to trigger Lambda, so this needs to be done. And as you can see, the Cognito host is given the permission to invoke Lambda function. And the next thing is the bucket, which will be created when this bucket stores the images that are going to be uploaded by the user when user posts the blog. So this is created from the cloud formation only. And from here to the send lambda function, this send email lambda function will be created by, so this function will trigger the emails to the user. So these are all lambda functions. The configuration is similar to the send email lambda. Now let's move to the gateway. So here a CF test gateway, this will create the API gateway. And this authorizer is configured such that the Cognito user pool configuration will be used to authorize the user from the API gateway. Then for each API, there are two resources that needs to be created. One is integration and another one is route. In integration, we specify which Lambda needs to be triggered for this specific route. And after integration is created, we will create the route. In this resource, we specify which integration the route needs to be triggered and the schema for the REST API. As you can see, for the delete blog route, this is a delete API and the host URL with the suffix delete blog and blog ID as a parameter. So this configuration is similar for follow and following and all the other APIs. Now let's move on to the Beanstalk. So here Beanstalk application is created. The Beanstalk application name, which we have given as a parameter, is referred here. So whatever the parameter name is given, that will be with that name, the Beanstalk application will be created. After application is created, the code will be uploaded, the S3 code, which has the docker run.aws.json. This code will be uploaded as to a version, so we can reuse this version for multiple environments. Then a template is created, configuration environment template. So this can be reused to create multiple environments with the same configuration. Then the environment is created here with the environment template and the code version, which we have created earlier. So this is the CloudFormation part. So let's go to the creation area. As you can see, it's still going on. Till now, everything, there are no errors. Let's go from start. So the creation process for the tables are triggered and lambdas are also triggered along with the Beanstalk application. So, okay. So as you can see, everything is created now. So let's go to the console panels and see everything is configured as we have as we want. So let's move to the API gateway first. So in here, CF test gateway. As you can see, in the routes, everything is created. Subscribe email, send email, post, blog, like, blog, and all. In the authorizations also, the authorizers, as you can see, the Cognito is properly configured. We can verify this information by going to the Cognito console. So the pool ID, I'm just going to copy this pool ID. So as you can see, the configured pool, the new pool ID which is created is configured to the authorizer. Now let's move to integrations. Here also, as you can see, for the comment API, the comment blog is created, Lambda. And as you can see, the corresponding code for the comment is added here. Now, let's move on to the CI/CD part. Yeah, here I have already configured the access key ID, secret key and session token, application name, and the environment name here. We just need to update code version, template and version. So I'm going to copy those from the console. So as you can see, it's still creating the application environment. So I'm going to copy the code version. I'm going to copy the template. Now I need to push the changes. I need to copy the user pool ID here. In the constants, the host URL needs to be changed because the new API gateway generates a new host every time we create. So I'm going to copy that. Here I need to change the topic ARN prefix because the account ID which we have used for our development is different from the demonstration. So I'm going to copy the account ID here. Now let's go to the so I need to change this user pool ID and client ID, which we have created through CloudFormation. Now I am going to commit these changes and push to the GitLab. So looks like there are some changes. I'll pull those changes. I'm just going to check whether these changes are up to date or not. Yeah, looks like everything is up to date. So I'm going to, so we push the changes to develop branch. Now I need to merge this develop branch to main branch to trigger the CI/CD pipeline. So I'm just going to create a merge request and I'll trigger them. So as you can see, the pipeline is triggered here and it's running. So in the meantime, I'll explain the CI/CD pipeline which we have created. So for the CI/CD, we created the entire front-end application. So whenever there is a change in the front-end code, the entire pipeline will trigger and the changes will be automatically deployed into Beanstalk. So for this, we in the pipeline, we built the entire React app using Docker, and we push the changes into Docker repository, as you can see, ECR here. And then after pushing the changes, we will create a new environment because for some reason, Volcarium doesn't allow us to update the existing environment in the AWS. So every time we need to create a new environment, and if we exceed the limit, we have to reset the account and we need to create again. So that's the uh, uh, limitation we have right now. So this is the CI/CD pipeline. Let's I'm just going to check the status. Okay. So this will take around 13 minutes. So in the meantime, I can explain a little bit of code, what we have written. So the code, all the code is present in the group repository created for us. So in the backend folder, we have all the Lambda functions code, and here it is. This function is triggered when user clicks on the delete button. So corresponding to that blog, it will be deleted from the DynamoDB. Now, this function is triggered when user clicks on follow or unfollow button. Based on that button, the user, the corresponding author will be followed or unfollowed corresponding to that user. And these are all the edge cases we need to handle. So that's why this much code is there. This function will be triggered uh, for getting all the blocks in the home page. This function is triggered when user clicks on the like button. Now post blog lambda, this will be triggered when user post the blog. This is the comment post comment lambda, and this lambda function will be triggered once the user confirms the sign up through mail. So this will essentially store the user data in the DynamoDB. So in a way, after confirming the user's email, only we will have the user information in the DynamoDB. This function stores the image information in S3. And this send email will trigger email notification to the user when a like or comment has been done. The subscribe email will be triggered when user signs up, confirming his subscription corresponding to the notifications. Uh, the front-end code, React.js code is stored in the front-end folder. And this Docker file specifies the Docker build, which we need to run for the deployment. Then, as explained, Docker run is the configuration file for the Elastic Beanstalk, which will be used to appropriately deploy the code into Beanstalk's environment. And this Nginx is used for, since we have used React Router, this Nginx configuration sets it properly so that the routing is properly handled in the client side. And in the source folder, we have all the code. And we have divided every component. The auth component handles the sign up, sign in, log out. The block component handles the blocks list, and each block, like the each block is visible as a block card, like that. This is for the comments UI, and this is the home page, which has all the header and the list of docs, etc. And this is the navbar. In the local storage, we are storing the user information like user ID, JWT token, full name, which we are using across all the services, all the components. Sorry. Here, routing is defined. As you can see, we have also defined protected routes, So without login, some protected routes can't be accessed, like post a blog or delete blog or comment on the blogs. These will not be accessed without login. So this is our application. Let's check the CI/CD pipeline. Okay, looks like the Docker image is still in build status, so it's gonna take some time. So as you can see, now the CI/CD pipeline is executed and the new environment with version 2 name is created. And we can go to the uh, AWS console. So in here, in the repository, the code is pushed to the latest tag. So this image is used to create the version 2 environment. So in here, so version 2 environment is created. And so here, because we have created everything from scratch, so we need to do the sign up again and all, because the data that we have demonstrated previously is taken from the another account. So I'm going to create a new, I'm going to create a new. So after sign up, as you can see, there are two emails, and I can verify this. So the registration has been confirmed, and I can also verify this confirm subscription. Now I can log in with this email. So since this is the new environment, no post has been created yet. So I'm just going to create the post. Just going to show around the uh, sorry, I couldn't. Okay, just going to post this without image. So as you can see, the blog has been created. And I can comment on the blog and log out. So uh, the last thing I need to cover here is, so we have created version 1 environment with the cloud formation stack, but it hasn't created properly because the code is not yet pushed to the Elast ECR repository. That's why it gave the error. And we pushed this code through CI/CD pipeline and created a new environment. Since we can't update the version 1 environment because of Volcarium permissions, so we have created a new environment. So that's it from my side.